All right, so are you ready to dive deep?
I am.
Awesome. Today we're going to be tackling how the universe built its biggest structures.
Sounds pretty epic.
It does.
Yeah.
And we've got this excerpt from Galaxy Assembly Lines.
Assembly lines. That's an interesting way to think about it.
Yeah, and just the title alone makes me feel like we're about to witness something just massively huge.
Yeah, the scale is really hard to wrap your head around.
Yeah, yeah. And it all starts with this idea that the universe isn't just empty space.
Right.
It's more like a giant factory that's constantly running. You know, stars, planets, entire galaxies.
Yeah.
They're all being churned out on this scale that's just mind-blowing. Like, you look up at the night sky, you see all these stars.
Mm-hmm.
But have you ever actually stopped to think about how they got there?
Yeah, it's one of the biggest questions in astronomy.
It is.
And it's a question that's been asked for as long as humans have been around. And the answer, well, we're going to find out, is this kind of wild ride through gravity and chaos and even a bit of cosmic recycling.
Oh, okay. I like where this is going.
Mm-hmm.
So the excerpt starts by painting this picture of the early universe as this, like plasma soup. It's kind of hard to imagine considering how organized everything seems now with galaxies and stars, all neatly arranged.
Yeah, it is a stark contrast, but that's what's so amazing. All this order that we see emerged from that initial chaos.
Yeah.
And the thing that did it, the architect of all this, is gravity.
Gravity.
Gravity. You can almost imagine it like it's playing the longest game of Jenga ever.
I like that.
Pulling together these tiny particles in the early universe to form these larger and larger structures.
Okay, so gravity's playing Jenga. I like that visual. But it wasn't just a smooth, gradual process, right?
Oh, no.
The excerpt mentions this early universe was incredibly hot.
Oh, yeah.
And dense.
Incredibly. Temperatures and pressures they're just unimaginable. And it's this extreme environment that leads to something really incredible, this thing called the cosmic microwave background radiation.
Okay.
So think of it as the faint afterglow of the Big Bang. And you know what?
Yeah.
It's still detectable today. It's like a baby picture of the universe.
Wow, a baby picture of the universe. That's amazing.
It is.
It's like we have this tangible evidence of this early, plasma soup era.
Yeah, it's this faint whisper from the very beginning.
Okay, but how do we go from this hot, dense soup to the stars and galaxies we see today?
Right, so as the universe expanded, it cooled down.
Okay.
And that cooling allowed gravity to start doing its thing.
Yeah.
Pulling together those tiny particles, forming clouds of gas and dust.
Yeah.
And that's the raw material for stars.
Okay, let's talk about star formation, because that's where I think things get really, really mind-blowing. So the excerpt describes this process as incredibly violent.
It is.
Which seems so counterintuitive. You would think creating something as beautiful as a star would be more peaceful.
Yeah. It's anything but peaceful.
Yeah.
So you have these giant clouds of gas and dust.
Okay.
They're called molecular clouds, and they're like battlegrounds where gravity wages war against pressure.
Whoa.
So as gravity pulls the cloud inward, the pressure inside pushes back.
Okay.
So you have this delicate balance.
So it's like this tug of war between gravity and pressure.
Exactly.
And eventually gravity wins.
Exactly. And when gravity wins, the cloud collapses in on itself. The core gets incredibly hot and dense. And then boom.
A star.
A star is born. But here's what's even more fascinating. The process, it's not very efficient.
Really?
Most of the gas in these clouds, it doesn't actually end up in the star itself.
Wait, really?
Yeah.
What happens to all that leftover gas? Does it just float around aimlessly?
No. It gets blasted back out into space by these powerful winds and radiation from the newborn star. It's this chaotic, explosive event, but it's also incredibly important.
Okay, I'm sensing a but coming. Why is all that chaos important?
Because that material that gets ejected, it's enriched with heavier elements that were forged in the star's core.
Okay.
And it becomes the building blocks for future generations of stars and planets.
Oh, wow.
So it's a cycle of destruction and creation. It's this cosmic dance between chaos and order.
So it's like the universe has this built-in recycling system. It's constantly repurposing material to create these new stars and planets. It's incredible to think that the atoms in our bodies and everything around us were once part of stars that lived and died billions of years ago.
I know. It puts things into perspective, doesn't it?
It does.
We are quite literally made of stardust.
Yeah.
It also raises this question. If we're stardust, does that mean there are pieces of Earth out there from stars that exploded billions of years ago?
Whoa.
Yeah.
That is a mind-blowing thought. Talk about feeling connected to the universe. But speaking of connections, if stars are the building blocks, what about the even bigger structures like galaxies?
Yeah.
How do we get from stars to galaxies?
So to get to galaxies, we need to scale things up like a lot.
Okay.
And that means talking about how those stellar nurseries we've been discussing, how they all come together to form these grand swirling structures.
Okay, so we're going from star formation to galaxy formation.
Exactly.
Is it just more that gravity-driven Jenga game on an even bigger scale?
It's more intricate than that.
Okay.
Though gravity is certainly the maestro of the whole thing.
Okay.
One of the key processes is called hierarchical merging.
Hierarchical merging.
Yeah, imagine galaxies as constantly bumping into and merging with each other.
Okay.
Over billions of years.
So it's like a cosmic game of bumper cars.
Yeah.
But with galaxies.
Very energetic analogy.
Yeah.
But there's a method to the madness. These mergers aren't random, they're orchestrated by gravity.
Right.
So smaller galaxies get drawn together, and as they interact, something fascinating happens. It's called dynamical friction.
Dynamical friction. Okay, that sounds intense. What is that exactly?
So think of it like this. When a galaxy moves through a sea of stars and dark matter, it creates a sort of gravitational wake behind it.
Okay.
And this wake, it pulls back on the galaxy, slowing it down. And over time, this slowing effect causes galaxies to spiral towards each other and eventually merge.
So it's like a cosmic dance with galaxies slowly spiraling inwards until they finally meet.
Yeah, that's a beautiful way to put it.
And these mergers, they're not exactly gentle encounters, right?
No. These events are incredibly dynamic. Stars get flung around, gas and dust clouds collide, and all this activity, it triggers these intense bursts of star formation.
Wow.
The antenna galaxies are a great example of this. They're in the midst of a merger, and when you look at them, you see these distorted shapes and these long, wispy tails of gas and stars. It's a testament to the immense forces at play.
Wow. I'm going to have to look up images of those later. So these mergers, are they constantly happening? Is that how the universe is structured?
They've been happening for billions of years, and they're a key driver behind the large-scale structure of the universe.
Okay.
We see this in galaxy groups and clusters, where you have hundreds or even thousands of galaxies bound together by gravity.
Yeah.
And these clusters, they form filaments and sheets. It creates this immense cosmic web that stretches across the observable universe.
It's mind-boggling to imagine the sheer scale and complexity of it all. But let's zoom back in for a moment and talk about our own galaxy, the Milky Way.
Okay.
We touched on this earlier, the fact that it's currently merging with the Sagittarius dwarf galaxy.
Yes.
Right.
A prime example of hierarchical merging in action.
Yeah.
And this ongoing merger isn't just a cosmic spectacle. It's actually giving us clues about our own galaxy's history.
Really? How so?
By studying those streams of stars and gas being pulled in from the Sagittarius dwarf, astronomers can trace back the Milky Way's past mergers. It's like a cosmic detective story, piecing together our galaxy's evolutionary history from the debris of these ancient encounters.
So we're learning about our own galactic past by studying this ongoing galactic merger. That's incredible.
It is.
It's amazing how interconnected everything is in the universe.
Yeah.
But speaking of powerful forces, remember we talked about supermassive black holes earlier.
Right.
Do they have a role to play in this whole galaxy assembly process?
They do.
Right.
They're not just cosmic vacuum cleaners lurking at the centers of galaxies.
Right.
They actually exert this profound influence on the evolution of their host galaxies.
Okay, remind me again how that works. They're both destroyers and regulators, right?
Exactly. So as supermassive black holes devour matter, they release these enormous amounts of energy in the form of powerful jets and winds.
Yep.
And these jets and winds can heat up and push away the gas and dust that would otherwise form new stars.
So they can actually stifle star formation. That seems counterintuitive considering how much energy they're releasing.
Yeah, it's a balancing act. Sometimes those powerful outflows can actually trigger star formation in nearby regions by compressing gas clouds and making them more likely to collapse. This process is known as AGN feedback, where AGN stands for active galactic nucleus, essentially a supermassive black hole that's actively feeding.
Okay, so supermassive black holes can be both friend and foe to star formation, depending on the circumstances. It's like they have this complex, almost regulatory role in shaping the galaxies they inhabit. But there's another player in this whole galaxy assembly story that we haven't talked about much yet. Dark matter.
Ah, yes, the invisible hand that guides the cosmic dance.
Okay.
We can't see it directly, but we know it's there because of its gravitational effects on the things we can see.
Okay, refresh my memory on dark matter. Why is it so important for galaxy formation?
So think of it like this. Dark matter is like the scaffolding that holds galaxies together.
Okay.
It creates these vast halos of gravity that draw in the gas and stars, providing the framework for these structures to form.
Okay.
Without dark matter, galaxies wouldn't have enough gravity to hold themselves together.
So even though we can't see it, dark matter is essentially the glue that binds galaxies together.
That's a great way to put it.
That's incredible. But it also sounds a bit frustrating, trying to study something that's invisible.
It's a challenge, but astronomers are incredibly resourceful.
Yeah.
By studying the motions of stars and galaxies and by mapping that cosmic microwave background radiation,
right,
we can infer the presence and distribution of dark matter, even though we can't see it directly.
It's like a cosmic puzzle, piecing together the evidence to understand this mysterious substance that plays such a fundamental role in the universe.
It is.
This whole conversation has been mind-blowing. It's amazing how much we can learn about the universe, from the smallest particles to the largest structures, just by observing and asking questions.
And we're only just scratching the surface. There's still so much we don't know about the universe. But every new discovery, it brings us closer to understanding our place in this vast and complex cosmos.
Well, on that note of cosmic wonder, I think we've covered a lot of ground in this part of our deep dive.
We have.
We've gone from star formation to the epic mergers that shape galaxies, and we've even delved into the mysteries of dark matter.
But the journey doesn't end there.
Oh.
In the next and final part of our deep dive, we're gonna take a leap into the future.
Okay.
Exploring the ultimate fate of these magnificent cosmic structures, including our own Milky Way galaxy. Get ready for a glimpse into the distant future where galaxy evolution takes on a whole new meaning.
Welcome back to our deep dive into galaxy assembly lines.
Yeah.
We've journeyed from the chaotic beginnings of the universe through, those epic mergers that build galaxies, and we even touched on the mysteries of dark matter.
It's been quite a ride.
It has.
Yeah.
But now I'm ready for the grand finale.
Right.
What happens to these incredible structures in the long run?
Mm-hmm.
What does the far future hold for galaxies, including our own Milky Way?
Well, you might say we have a date with destiny.
Oh.
A galactic encounter of epic proportions.
Okay, you've got my attention. What kind of encounter are we talking about?
Remember our galactic neighbor, Andromeda?
Yeah, that beautiful spiral galaxy we can sometimes glimpse in the night sky.
That's the one. Well, it's not just sitting there looking pretty.
Okay.
It's hurtling towards us at a speed of about 250,000 miles per hour.
Wait. We're going to collide with Andromeda.
We are.
Like 250,000 miles an hour.
That's right.
That sounds pretty serious.
It is a cosmic collision of epic proportions.
Yeah.
But don't worry, it's not happening tomorrow.
Okay.
Astronomers estimate the encounter won't happen for another 4 billion years or so.
Okay, 4 billion years. That gives us some time to prepare, I guess. But seriously, what happens when two galaxies like ours, decide to merge? I mean, is it as catastrophic as it sounds?
It's definitely a dramatic event, no doubt about that.
Yeah.
Stars get flung around, gas and dust clouds collide, triggering these intense bursts of star formation.
Okay.
The shapes of both galaxies get distorted as they interact gravitationally.
So it's not exactly a gentle embrace.
Not exactly. But But here's the thing to remember. Galaxies are mostly empty space.
Okay.
So the chances of individual stars actually colliding are surprisingly slim.
Okay.
It's more about the overall gravitational interaction and the disruption of those neat spiral structures that we're used to.
Okay, that's slightly less terrifying. So what happens after all the dust settles?
Right.
What is this new merged galaxy? What does it look like?
So astronomers predict that the Milky Way and Andromeda will eventually coalesce into this giant elliptical galaxy. Some even have a nickname for it. Vilcometa. I love it. It has a certain ring to it.
It does.
But what happens inside Milcometa? Do the stars just like hang out, or is there more to the story?
The story continues.
Okay.
Inside Milcometa, stars will continue to evolve, age, and eventually die.
Right.
New generations of stars will be born.
Yeah.
In the interstellar nurseries created by the merger.
Yeah.
The cycle of cosmic life and death, it keeps going even on these grand scales.
Even after this epic collision, the universe just keeps on creating and evolving.
It's almost reassuring in a way. But what about the even bigger picture? What's the ultimate fate of the universe itself? Is it all just going to end someday?
That's the ultimate question, isn't it?
Yeah.
Cosmologists are still debating the details.
Okay.
But there are a few leading contenders for the universe's grand finale.
Okay, hit me with those contenders. What are the possibilities?
One scenario is the big freeze.
Okay.
As the universe continues to expand, galaxies, they drift farther and farther apart.
Yeah.
Eventually, they become isolated islands in this vast, cold, and empty cosmos. Star formation ceases.
Right.
And the universe slowly fades to black.
That sounds a bit bleak.
It does. Another possibility is the Big Crunch.
The Big Crunch.
Imagine the expansion of the universe slowing down, eventually reversing.
Okay.
Everything collapses back in on itself in this fiery inferno.
Wow.
A cosmic implosion. It's almost like a reverse Big Bang.
That's a dramatic ending. But it also raises a question.
Yeah.
Could a Big Crunch lead to another Big Bang? Could the universe be like cyclical?
Right, constantly expanding and contracting.
Yeah.
It's a fascinating idea.
Yeah.
Some theories propose just that, a never-ending cycle of cosmic birth and rebirth.
Oh, wow.
But there's another contender in the ring.
Okay.
And it's perhaps the most dramatic fall, the Big Rip.
Okay, the Big Rip.
Lay it on me.
Yeah.
In this scenario, the expansion of the universe not only continues, but it accelerates at an ever-increasing rate. Yeah. Eventually, this accelerated expansion becomes so powerful that it overcomes all other forces, tearing apart galaxies, stars, planets, and even atoms themselves.
So it's not just the end of the universe.
Right.
It's the end of everything.
Yeah.
No more matter, no more space, just nothingness.
Mm-hmm. It's a rather extreme scenario, but one that's being seriously considered by cosmologists. And here's where things get even more interesting. A mysterious force called dark energy is thought to be driving this accelerated expansion.
Dark energy, another cosmic mystery to add to the list. So what's the verdict?
Mm-hmm.
Big freeze, Big Crunch, Big Rip. Which one wins the End of the Universe award?
The honest answer is we don't know yet.
Yeah.
The universe is full of surprises, and the ultimate fate is still a mystery waiting to be unraveled. But that's part of what makes cosmology so exciting.
Right.
We're constantly pushing the boundaries of knowledge, trying to understand the grandest story ever told, the story of the universe.
I have to say this deep dive has been incredible. We've gone from the birth of stars to the death of galaxies, and we've even contemplated the end of the universe itself. It's overwhelming, but also incredibly inspiring.
It is. It is.
Yeah.
It really puts things into perspective, doesn't it?
It does.
We humans are just a tiny part of this vast and ancient cosmos.
Yeah.
But we have the ability to observe, to question, and to try to understand it. That's a pretty remarkable thing when you think about it.
Absolutely. And who knows, maybe someday we'll be the ones to solve the mysteries of dark matter and dark energy and the ultimate fate of the universe. Mm-hmm. But for now, I'm content with the awe and wonder that this deep dive has sparked.
Mm-hmm.
It's a reminder that there's always more to learn, more to explore, and more to discover about the universe we call home.
Well said.
Yeah.
Keep looking up. Keep asking questions and never lose your sense of wonder.
Yeah.
The universe is full of incredible stories waiting to be told.